The next step we will perform in ECAM is the definition of points. For our simple file here, this is not a big deal, but we'll use it to demonstrate the process. The value of defining your points per the standard point naming convention that's in ECAM is it provides some additional automated calculations. For example, if you have a consistent set of data, it will automatically calculate tons from chilled water temperatures and flows. It will calculate a kW per ton. It will normalize any power measurement or power point by square footage if you input the square footage, various things like that. So it automates some other things that you may do as part of your normal energy analysis and makes it a little bit easier in that fashion. Another value of identifying your point names is that if you're going to use the PNNL building retuning process, having the standard point names is required to have those charts created automatically. So the first thing here is we get prompted, we go to the ECAM menu and select definition of points. Let me repeat that. Well, I already clicked OK. We can just close this and ECAM, second menu item, definition of points. I'll just leave the building area. Well, this happens to be, if I remember right, it's 294,000 square feet. What is the voltage for three-phase equipment? This allows us to calculate power. This is not obviously an exact calculation, and it doesn't work in all circumstances, but we try to make things very easy to handle the vast majority of circumstances. Okay, then we click OK, and now we get a points list, and each of these columns to the right, the empty fields, are filters to allow us to identify a specific measurement. If we didn't have this, there's a list of 120, something like that, point names within ECAM. So if we had to scroll through a list of 120, it would be somewhat difficult. But in this circumstance, we just filter by these individual things. And so our kW here, we happen to know this is the electric meter, so we select the electric meter here, or the meters subsystem here, and then we know it's an electric meter and it's a measurement of power. So our standard point name is electric meter kW. Click map point here, and now you can see that our point name shows up here under the mapped points area on the left, which confirms to us that our point was successfully mapped. Temperature is associated with the building. It can also be associated with an air handler. This happens to be the temperature associated for the whole building. There's only one choice here, and building temperature OA, so for outside air temperature. Click map point, and it's been mapped now. And that's all we need to do. If we had other points or duplicate points, say for example we had some air handler points here, then we can have multiple air handlers. So we have this component ID number here, so each air handler we can give a number to. Perhaps you want to use the number that corresponds to the actual air handler number at the building, but then you can, by using this, you can increment for each air handler you input the temperature for. For example, if you're inputting a supply air temperature for an air handler, you'd have it for air handler 1, air handler 2, etc. So that's all we need to do to define points. We click done, and now the only change we see here is our standard point names are now listed here in the first row of our data, and our original point names are put up here for reference, so that if you don't recall what your point name, the standard point name is, but you're familiar with your building, you have this here for a reference. That's all there is to using the standardized point naming convention in ECAM.